Okay, solve the equation. So we've been working on using the distributive property. Today I'm going to tack on to this a little bit and show you more. So to start off with distributive property, we're going to take negative 3.2 times 5d. What is that? Negative 16. D. And D. And then this is a negative 3.2, and technically that's a negative 7. So that's going to make a positive
22.4.
Okay. 22.4 equals negative 17.6. So at this point, I need to subtract 22.4 from both sides, which means these are both negative. So I add these two together, and I think I get negative 40.
Yeah, negative 4.8.
And then, because this one started off in decimal, I'm okay with you leaving the final answer in decimal. But I told you guys that anytime that we are doing this, if we start in integers, I want you to end it as a fraction. Because this could easily be written as a fraction. This could be negative 16, and this could be divided by negative 16. Negative over a negative makes a positive. You could say that, what, 4 goes into both of those? So that could be, what, positive 10 over 4, which would be 5 over 2. So you could say that, but because this started in decimal, I would accept the answer of 2.5.
I don't understand what this starting.
I don't either.
Understand what?
I just messed up.
No, I needed a specific question so I can help fix it. Hayden.
Well, I didn't have a question. The only thing I messed up on to get a different answer was the plus and then negative 7.
Okay, well, because anytime you have a subtraction sign, you can change it to plus and negative. Or you can think about this as negative 3.2, let's see, 5d minus 7. Okay, so if I multiply it here, I got my negative 16d. This would be subtract, and what's a negative times a positive?
Oh, a negative.
A negative, so then you would say negative 22.4, and what happens when you have subtract a negative? It becomes the plus a positive anyway. So either way that you want to think about it is fine. Sophia?
For the answer for number 1,
Yes.
can you change it into a mixed number?
Of course you could. Yes. If you want to put 2.5, that would be perfectly fine. Yes. Anything else on that one? James?
Do we have more of those?
Well, today we're going to be doing a lot of these, so we'll have more practice.
And can we do it on whiteboards?
We're going to do some practice on whiteboards too. Yep. All right, number 2, circle equations that require more than 2 operations, okay? So you should know that this one only takes 1 operation, so that is out. This next one would definitely take more than, because you'd have to distribute and then do all of that, okay? Same with D, that's what I was going to say. Now, C, I think you could argue C either way, because I think you could say it's going to take more than 2 because you're going to have to add 6, and then after you add 6, you would also have this right here, and you could technically count that as a step if you wanted, or you could say you have to divide twice. So I think you could debate that one either way. Does that make sense? So yes or no, depending on how you thought about it. Yes?
Those kind of questions related with us.
I don't know. Maybe, maybe not. If they're on the practice, then we'll make sure we get it the right way. Yes, James?
These questions, do we have to do them on that, or can we do it like on Smart Notebook and then answer there?
What are you talking about?
Like the warm-ups? Because there's not enough room to write.
What I would do if it were me is I would add another slide and write on that slide. You know, just insert a slide. Okay, next one. All right, this is one that threw last hour a little bit, so make sure you watch as I go through it. Okay, so we have 3 times 11 is 33r, minus 3 times 13 would be 39, equals, now I have negative 7r and a positive 32. I need to put those two together, and that would be a positive 25r. 25r plus 57. Okay, once I get it to here, this is the same thing we've been working on the whole time. So I need to get my variables together. I would subtract 25r from both sides because it gives me a positive variable. Doesn't mean that's what you had to do. Okay, so then on this side I get what? 8r minus 39 equals 57. Then I'm going to add 39 to both sides, which is 96. Okay, so 8r equals 96. Or some of you, if you did it differently, you might have this. You might have negative 96 equals negative 8r if you did it a different way. And then you divide both sides by 8. And r equals 12. Okay, specific questions on that one? Somewhere that you got thrown. Sophia.
Would it have changed the answer if instead of doing 33R, you did 33 minus 3R minus 39?
Say that again?
33 minus 3R
Minus 3r. Where do you get 3r?
I only distributed the 3 to the 11, then cut off the R.
Oh, we can't do that. Nope. Yeah. All right, anything else? Yeah. Oh, yeah.
Well, you have to add the 32R.
Why do I have to add the 30?
You have to put them together. Why can't you just solve them separately?
The which one? The 32 and the 7?
32R and the -7. You said you had to put that together, which made it 25.
Let's see. How's the best way to explain that? Because what did you get at the bottom then? Then you had to, so you brought r's over twice?
Well, I didn't add them, and I just and then I just subtracted -32R from each side.
And then you would have had to do the 7 too.
And then I did the R minus 39, and then the -7R plus 57, and then I just subtracted an R.
Okay, so hear me out real quick. So by doing that, you had to do more steps than I did. Does that make sense? You still get the same answer, but I'm trying to make less steps. And as they get bigger, you're going to be happier this way, but your way works mathematically. It's just longer. Okay? All right, so let's look at our learning goal today. Our learning goal today is what happens basically when these come out as either no solution, infinitely many, and then the other one is one solution. Everything we've done up to this point has been one solution. When we get r equals 12, that is a solution. We just found that r is 12. But that doesn't happen every single time. There are problems that don't have a solution. There's no way to solve them. There's also things that are called infinitely many. Infinitely many, if you know the word infinite, what does infinite mean?
Forever ending.
Never ending, goes on forever. So infinitely many means every single number in the world works. Whether it's a decimal, fraction, anything. Rational numbers, irrational numbers, everything in the world works that you would want to put in there. Okay, so let's look at what happens when that occurs. Okay, so look at this slide right here. We're going to start off number 1, solving it the same way. Okay, all of this algebra stuff's the same. So I'm going to draw a line, and I'm going to start off with my 9z plus 12, and then I'm going to distribute my other side. So 9z plus 9 times 3 is 27. Okay, I've always told you to do what first? What? Get your variables together. So this is probably where your brain starts going, what? What's going on here? Because if I take away 9z and I take away 9z, there are no more z's. That's a problem because right here becomes 0 and all I have left is 12. Right here becomes 0 and all I have left is 27. Okay? So when I look at that, 12 does not equal 27. That is not true. So we say that they're not equal, and we draw a line like so, and then this is a no solution. So I'm going to write no solution.
But doesn't it have a solution? You just couldn't figure it out that way.
No, because if we go back to this step right here, okay, can you tell me a number anywhere in the world that I can take times 9 and add 12?
Yeah.
And it be the exact same number as if I say the same number times 9 and add 27. No, there's no way I can add 12 on one side and add 27 on the other and expect to have the same thing on both sides. That's why it's no solution. There's just nothing anywhere that's going to work for that, ever. Even if you put in 0, because if you put in 0, you're going to get 12 and 27, which is not the same. Please.
And if you had like a question like that on the test, wouldn't it have to be like multiple choice and have one of them be like no solution?
Yeah, exactly correct.
If there's no symbol for no solution.
There's no, you would write no solution. That would be your answer. Okay, but you do need to be able to see it because they might say, you know, what is this? And you'd have to be able to say, this means no solution. Okay, let's look at the next one. So next one has 2 parts I have to distribute. So 4 times 3x is 12x plus 4 times 2 is 8. 2 times 6x is 12x plus 2 times 4 is 8.
That's exactly the same.
Okay, now hold on. Let's go ahead and use the algebra for a second. So the first thing I would do would be to subtract 12x. Subtract 12x, which the same thing happens again, except I drop down an 8 and I drop down an 8. That's true. 8 does equal 8. And some of you, before I even did that, said, wait a minute. Those two sides are exactly the same. Okay, both of them say 12x plus 8. So when you look at this, every single number I put in here, and I multiply by 12 and add 8, is going to give me the exact same thing if I put in the same number here, multiply by 12 and add 8. So this is infinitely many. I can put in any number in the universe for x, and it's going to work. Okay, so you're going to write infinitely many. And I never can spell infinitely many. E-L-Y, I think. Infinitely many. Who are my good spellers in here? I think I put it on the slide above. Did I spell it right, Alex? Am I close?
That doesn't look right though.
Have you
Well,
spelled infinitely right?
Here it is. I-N-F-I-N-I-T-E. I think I got it. If I sound it out.
Yep.
Like my third grader. If I sound it out.
Oh, you just
Infinitely. Yes.
All
All right. All right, so if you go to the next slide, right here, I have put a little bubble that talks about the different types of solutions, okay? So the first type of solution is one solution. One solution looks like everything we have done up until this point. You have a variable equals something. That's one solution, okay? Next thing, you can have no solution. No solution is what we just talked about. That's when you get two things that are not equal. And the last one, you can have infinitely many, and that's when the two are equal to each other. So what I would like you to do is I'd like you to go through these, and I want you to draw arrows to whether you feel like each one is one solution, no solution, or infinitely many.
You can drag them.
If you drag them, that's great. I don't think it will go in there like we want it to. Okay, then great. Go ahead, do it. Yep, because those are exactly the same. Okay? All right, moving on. All right, I would like you to work. Let's do this one right here. I'm going to have you work that on your own. You figure out what you think it is, and then we'll go over it. Okay? And this one says, where is the first time that you can tell that this is a no solution? Without getting all the way to the bottom. Jacob?
When you see both of them have 4n.
Okay. Now, when you see both of them have 4n, they could be infinitely many or no solution. So how do you know at what point it's no solution, James?
Because 4 and minus 9, 4 and plus 9.
Are different. Very good. If those two are different, there's no way I can subtract 9 on one side and then add 9 to the other and expect to get the same thing on both sides. Malia.
With the 0 minus 9 and the 0 plus 9.
Of course, yes, you can see it here too and here, but this says where at what point do you first recognize. The first recognition should be right in here, that you're like, okay, these two aren't, this isn't going to work. Does that make sense? All right. I want to make sure we have some time to practice. So I'd like you to go ahead and go to the practice slide.